Yeah, good afternoon. Thank you, Greg, for the introduction and for the invitation to speak. It's really a pleasure to be with all of you today. We've had really an incredible year in exploration systems development with the recent Artemis 1 flight, naming of the Artemis 2 crew, rollout of our architecture definition approach, and really much more progress across every element of our systems and architecture. It's an exciting time for space exploration and science, and I'm excited to talk with you today about our part and the remarkable work happening to set us up to learn more about the solar system. And we know your research is the foundation of our understanding of the environment, and that applied science is really what we need in order to build our system. So thanks for the opportunity to be here today. As I mentioned, we flew Artemis 1 late last year, and what a fantastic mission it really was. Our Artemis team launched the Space Launch System rocket and sent the Orion spacecraft on a historic, groundbreaking 25.5-day, 1.4 million mile journey around the moon and back, well exceeding the mission's primary flight objectives. We performed an end-to-end demonstration of all mission phases and ground support facilities, including that wonderful safe landing and recovery of the Orion crew module. The team executed 145 test objectives, 21 more than we had planned at launch, validating the safety and performance of NASA's deep space transportation systems that humans will rely on for all of our future space exploration. Even more important, we made science a priority. During the mission, we conducted critical scientific experiments that are helping us better understand the lunar environment. We did have vital science data about the environment and protective measures for our future crews that we captured on Artemis 1 through payloads inside Orion and the CubeSats that we deployed from the Space Launch System. The payloads are helping us fill gaps in our knowledge of the solar system as well. Artemis 1 was a flight test, as we said many times, and accomplishing those objectives that I mentioned were critical to ensure we're ready to carry this magnificent crew on Artemis 2, setting us up for a cadence of missions that would lead to a long-term presence on the moon, all centered on scientific discovery. Over the past year, and I know Jake has talked with you about this, we've rolled out our Moon to Mars objectives, the guideposts for what we want to achieve at the moon and at Mars. Those 63 objectives, 23 which are science oriented, are the foundational cornerstone for helping our team build a science-driven architecture and what we use to formulate our architecture definition approach. I want to emphasize again that over half of the Moon to Mars objectives are science objectives when you add those 23 and what we have across the other three categories that are all science focused. Using this approach, the agency for the first time is 100% mapping our strategy to our elements. It's important to note that our architecture definition process is not just a one and done effort. It's a process we're going to go through every year. Earlier this year, we held our first architecture concept review. Our next architecture concept review will be held this November and every November thereafter to align with our budget cycles. And this first architecture concept review focused on two aspects: getting our process down and getting buy-in from senior leaders across the agency, as well as putting that process to practice to distill the objectives related to our human lunar return, that first segment, in a series of segments to build a lunar ecosystem and eventually send humans to Mars. If you go to the next one, please. We broke the architecture into the segments I mentioned to facilitate our incremental development and deployment of elements. Each segment is a portion of the architecture with one or more missions or use cases. This approach allows us to break the architecture into those manageable pieces to focus and prioritize our analysis work and coordinate with our partners internal to the agency and external. Each of the segments increases the complexity of our missions and helps shape that blueprint for space exploration, which is the foundation of our objectives. Human lunar return was the initial capabilities, systems, and operations needed to reestablish a human presence and conduct initial science on and around the moon. Next is foundational exploration, expanding our capabilities to support, no, you can stay, thank you, to support more complex orbital and surface missions to conduct even more scientific investigations. And after that is the sustained lunar evolution, where we reach a point where our capabilities support global scientific discovery, economic opportunity, and a steady cadence of human presence, truly realizing our lunar ecosystem. And finally, we have Humans to Mars, where we take what we've learned on the moon and build that initial capability system and operations necessary for humans to step foot on the red planet. As I mentioned, our next architecture concept review is November, where we'll focus on that Humans to Mars segment, as some of the near-term needs for further foundational exploration segment definition go on as well. In the Human to Mars segment, we'll decompose those related objectives, garnering the details that will help us understand the long-term investments to the larger architectural components needed to make a crewed mission to the red planet a reality. We can find early prototype developments for many of the systems we'll likely need for Mars in those 3 lunar segments, and the ability to identify those common systems will provide an additional level of confidence for the early Mars missions. The segments will overlap, and we won't need to complete one to start another. However, each segment builds on each other with some of the capabilities that we have. In human lunar return, we'll establish that presence I mentioned, and in foundational exploration, we'll add to it with habitation and mobility elements as well. Each of the segments and each mission has an opportunity for scientific discovery. On Artemis 2, we'll conduct a tremendous amount of human research while we test our vehicles. We've named the project scientists for Artemis 3 and Artemis 4 and made a call for astronaut-deployed payloads for Artemis 3, all to meet the objectives. As we decompose the objectives, we're seeing technologies and systems that we need to develop to give us the scientific answers we're looking for. Everything we're doing for science. Along the way, we want feedback on the architecture. Last month, we hosted 2 workshops, one for our international partners and another for industry and academia. At both workshops, we had significant discussions on how science is driving the architecture. We'll continue to solicit that feedback. I know Jake talked to you about your feedback, whether that be through workshops or conferences or regular meetings that we have, or even sessions like this. Every interaction is an important opportunity to exchange knowledge, engage, and strengthen the architecture. Go to the next one. And let me stress for you that real hardware is in development to support these missions. Here you see great depictions of everything we have going on through Artemis 5. I know there's a feeling of, hey, we're pressing to get to 3. We're pressing to get to all these missions. We have metal being cut all the way through Artemis 7 and contracts out through Artemis 9. This shows that some of that status really being built across the world. And I can promise you there's a lot more coming. And now there's an approach to develop a long-term architecture for exploring the system to apply this hardware to. You go to the next one. I'll take questions after Lori's done, but I'd like to leave you with a similar thought that I left you with the last time. It's the idea that the moon is a destination, that Mars is a destination, and that other places in the solar system eventually will be a destination as well. We're going to the moon because it's of scientific value, but it's also a place close to home where we can test the systems and develop our technologies. We're also going to Mars because of its scientific value. One celestial body does not preclude the other. We're hopeful that in this sustained evolution or sooner, we'll see our international and industry partners increase our science capacity at the moon and make longer stays for astronauts possible. With partners at the moon, we'll be able to create a scientific ecosystem of discovery with endless investigation opportunities. And when we've done that, we want to apply that blueprint to farther destinations, including Mars and other potential destinations in the solar systems. Thanks so much for having me today, and I look forward to hearing your questions after we have the great opportunity to hear from Lori.
Jim, thank you so much.